And hello, everyone. Really excited to be talking to all of you guys. If this was a physical conference, I would basically say that, since this is the last talk, I'm between you and the beer session. Now this is virtual, so we can get creative here. But we sort of getting into, what this talk is about. When you think about, behind the scenes of an ML model, right? There's this classic paper from Google that talks about what it takes to actually deliver an ML model in production, right? And they have this nice visualization of the time spent, the effort involved, trying to highlight definitely the fun part of building the ML model, the ML code, and then everything around it that needs to happen, right, in order to get this out there. And as Nisha said, having sort of built this for several years, in fact, been generally in this area for 2 decades and led various different, I would say, in different verticals, initiatives involving both data, so leading teams on data engineering and data scientists, getting to see the whole picture, right? So this talk, I really wanted to focus on what you refer to as the data ops side of it. That is the raw data that then gets transformed or needs to get built out as discover, prep, build, and operationalize to truly get the ML model in production. Again, it could be an offline, online model, continuous training, so on and so forth. But end of the day, there is data and multiple data pipelines that need to work robustly for getting the model in production, right? So behind every successful ML model is a successful set of data ops that have gone in, right? Now, as I was thinking about this talk, right, I was just picking up my notes across lots of different experiences, building data products, launching ML models, including work that I'm recently doing at Unravel, my previous experience with Intuit, so on and so forth. The interesting stat here, just to give you sort of a glimpse of it, is that when you talk about data ops, there are no specific 1 or 2 areas. The issues tend to be all over the place, right? And it tends to be, in some sense, there's no silver bullet when it comes to how do I really create a robust data ops platform. How do I become robust with my data ops, which is really the lifeblood. In fact, if you look at statistics out there, VentureBeat, Gartner, and so on, the predictions are fairly grim. They talk about 80% to 85% of the projects never seeing the day of light. Because guess what? Even if we have a model that we have prototyped in production with all the noisy data that needs to continuously come in a reliable form to sort of ensure that we're delivering value, this is where a lot of things break down in terms of making things happen. So in the 30 minutes I have, or a little less than that, I wanted to sort of cover 2 aspects. One is I wanted to start off by sharing some battle scars, right? And 10 is a popular number, so I decided to go with that. But really, we'll take some of them depending on how we're doing on time, right? This will give you a sense of what happens on the ground, right? So this will sort of give you that perspective. And the second piece I want to get to is practical advice in terms of how do you map it back in your data ops, because this is really a very critical thing, especially as a data user, a data scientist, a data analyst. These are really the hurdles that are critical, right? So without further ado, I'm going to jump into the battle scars as I'm referring to them. So the very first battle scar, and again, you'll pretty much see a same format here for the slides that follow in the battle scars bucket, right? So I basically start off by describing a battle scar. This is actually a real situation, right, that has been encountered. Obviously, the details have been anonymized, but it's a real pattern. And within this context, I'm also talking about how we went about solving it. How did we solve the situation so that does not happen again, right? So my favorite battle scar is, I thought the attribute means something else, right? When you're looking at data attributes, in fact, there are a lot of assumptions we make, like, just picking on some of my experiences here. If you look at data sets, the way the attributes are named, you'll pretty much find multiple data sets with the same attribute names with _1, _2. Any permutation you can think of exists, right? And typically, while building out a model, you're looking to solve a problem. And to solve the problem, you're looking at data sets and the attributes to use as input, right? Input features. And this is, I would say, the #1 battle scar from the standpoint of making incorrect assumptions about the meaning, whether it's a source of truth, who are the owners of this data, what kind of versioning has happened, in a sense, has the definition changed over time? Really, is this data set trustworthy? So that's a scar. Now, the approach that, I'll also be talking about at a high level, what was done, right? So this is where the approach has basically been, how do you make this self-serve for the data users, right? You can always talk to people, go to a data engineer, try to use tribal knowledge, but at the end of the day, the best way to address these scars has basically been focusing on automating and making things self-serve, right? And the approach, when you think about building a service like that, I think of it as a Maslow's hierarchy, right? It's like food, water, shelter. Then you build entertainment. Then you build spiritual advancements. Like everything else, you have to think about it in a form of crawl, walk, run. Right? So in this case, our approach was basically building actually a metadata catalog, right? And within a catalog, what really goes on is, at the very basic level, you need to have technical metadata. Where is data coming from? How is it structured? Which format it is in? On top of that, you have operational metadata. Where is the lineage? What has transpired? And then on top of that, you further append with tribal knowledge in terms of business semantics, business attributes, so on and so forth, business vocabulary, right? And obviously this space, when I say build, the build essentially means leveraging. There are various different tools out there. And again, I'll be focusing more on open source, but open source cloud, these are solved problems. So wherever you see the word build, it doesn't mean you need to go and build it unless you have something specific, but really leveraging things that are out there, right? And like this is an example where at Intuit, we built out this open source framework called Superglue, right? And Lyft has something called Amundsen. You have Apache Atlas. And just to give you a flavor, right? These are the kinds of tools that do lineage tracking, right? So any given table, any given object, you get to see what are the transformations that have happened before this table was created, right? So that question of, I thought this means something else, well, go and trace the lineage, figure out exactly what's going on, how this attribute was derived, and making it self-serve. Because as data scientists, you need to do this very often. So this has to be as fast as possible. Now, obviously, the reality, and this is something I'd like to show, is that the reality of these dependencies tends to be huge. Like if you're expecting a well-structured view of the world, that doesn't exist. But nevertheless, this is a kind of battle scar, and this is an approach to fix it. Then you go to battle scar 2, right? This is another battle scar where the very first thing is, when you have a business problem, it's like, where are the data attributes I need for my model, right? And I'll give you an actual experience here, is that we're building a forecasting model for customer support. And the whole idea was, how to efficiently staff support for variability and a bunch of things. And huge number of features that we wanted. And there was this one specific set of feature where it was siloed across business units, right? 4+ months spent just connecting with the data stewards for these silos and business units that had the data before you can even get to building the model, right? And again, long story short, the biggest time consumer in actually sort of launching this wasn't actually the model building part, right? It was getting the data set, cleansing the data set, the whole 9 yards of even locating, is this reliable? Is this a one-time dump? Is this a reliable feed? So on and so forth. So this is the next battle scar, which is really getting to the data attributes. And our focus here essentially was, hey, build out a search service, like make sure, even if you have silos, right? How do you make it very easy? So not just, the first one was focusing on the metadata, given an attribute, how do I figure out its history? This one is more in terms of even figuring out what's where, right? Because as teams grow, this becomes more and more difficult. And if you think of a search service, again, the crawl, walk, run. Number one is let's just index the data sets and artifacts. Artifacts here could be, ETLs, reports. There's a lot of reinventing the wheel that happens in this bucket. Having the right search relevance ranking, access control. And again, this is an area where as you go out, look for tools. There are good examples. In fact, if you look at the Google Cloud, like, this is something very interesting where you can actually have this index and search across all the data sets, the different artifacts that exist, so on and so forth. Okay, I'm just going to go rapid fire. This is like a Jay Leno top 10 kind of a model that we're following here. The next battle scar, and this has bitten me infinite number of times. In fact, it bites you almost daily, depending upon where you are in the data platform maturity. Is data movement. There were 1,000 rows, and 1,000 is a number, but just there were X rows in the source database. I moved it in a lake, and I only have a subset. What happened, right? And this is one of those where the number one thing, and there's again an experience here, is a lot of companies have built internal tools to move data, right? And when you move data, you're moving from one data store to a different data store, thanks to our big data evolution of using the right tool for the job. You have several permutations, and ensuring completeness, timeliness, correctness of this data is actually a major hassle if you do this in production. See, again, for prototyping, that's fine, you can get the data, but how do you make sure that that pipeline that's feeding the actual data set, feeding into your insight or your model, is actually getting populated correctly on a regular basis? It could be hourly, daily, or even real time. And the focus here, again, let's fix it with automation. And how do you really simplify in the space of ingestion, transformation, and change management? So those are that's the way we focus on having a basic ingestion framework. And if you're in the cloud, there are multiple tools out there, like AWS, for instance, has a data migration and a data moving tool that is available, right? Also within this, there's typically a need where when data is ingested, it is also transformed. So the idea would be to not just move the data, but kind of gradually building the capability. So as a data scientist, I should be able to come in and basically say, move table X from this transactional database into this schema in my data lake, and maybe do the transformation of the timestamps, or any other change in the process, and be able to also do change management. So that's basically a way to address this, a very common problem that exists. I'll do a few more just along the lines here. The fourth battle scar, essentially, report creation, job completed, but guess what? The graphs have missing data, right? Now, this could be a report, it could be a model that you're regularly training, but oftentimes the training, if you go and actually look, there may be some attributes which are null or did not really populate. And this sort of gets into the world of job orchestration, right? So when you think about these regularly scheduled jobs, not the ad hoc ones, but when you're actually, again, from a production standpoint, you are looking at creating scheduled jobs, Airflow, Uzi, pick your favorite scheduler. There are several times where the job dependencies are incorrect. And what that leads to is that you will trigger the final job, even if some of the other data processing hasn't happened, right? Huge issue. And again, today, if it's not automated and not self-serve, you tend to run into data users getting frustrated on the data engineering or the platform team and so on, right? So the approach here is, how do you think about self-serving, or how do you build a self-service for the orchestration framework, right? And here it is, again, the basic crawl model here is making job dependency definitions very simple to define. I think things like Airflow do a great job. Especially if you look at some of the enterprise frameworks like AutoSys and Tidal, there's some scripts that can be built in terms of really making sure that dependencies could be in a domain specific or more of it gets transformed, right? On top of that, robust job execution, like a lot of these tools, oftentimes, debugging to make sure that there is a right retry. Jobs do not always work one shot, but that doesn't mean it fails. There has to be intelligent retrying to push these data pipelines through, and then really building out production monitoring. So that has been the mantra in, for this kind of a battle scar. You nail it one time by actually going through this crawl, walk, run approach, right? Moving right along, this is another one which happens, I would say, very frequently, which is, hey, the processing house is supposed to complete at 8 a.m., right? It's 4 p.m., I'm still waiting. I'm going to do a model retraining or whatnot. What's going on, right? And this is the part where oftentimes when these data pipelines are written, right, these pipelines, given distributed systems concepts, given how to tune a job, how to build the right mappers and reducers, how to allocate the right amount of memory, vcores, and so on, it's highly non-trivial, right? And the biggest battle scar I've seen here is that this was running, but something happened, especially when you have more data coming in, where the way the app was written, the data processing was written, be it Spark, Hive, or any permutation, it was not designed, it was not tuned well, it wasn't optimized well, did not use the formats correctly, so on and so forth, right? Now, the interesting thing here is there are a plethora of technologies. There is no gold standard. And having or finding that kind of approach, or finding this ability to actually continuously tune, is highly non-trivial, right? So again, the approach here is, very basic, being able to aggregate all the information about job level, query level, resource level. At least you have visibility. Next level there essentially is sort of correlating the stats, understanding what's going on, and then finally being able to tune jobs that are built. Again, an interesting bucket. I have actually built this, in terms of how this can actually be done. At the same time, there are a lot of tools, both in the open source, like Dr. Elephant as an example, so on and so forth. So we can happy to share more pointers as we go along. Just keeping up, tracking time. I'll do maybe this one more, and then I'll switch over to the second piece of the talk. Just continuing a battle scar. This is in the bucket of governance. Customer indicated no email marketing. And we are still including them in email campaigns. Have been on the other side where this has happened, and this is really one of those where, how do you get ahead of it? How do you ensure that with data rights, the preferences are correctly taken into account? How do you correctly track a customer? Like even identifying a customer, if you think of a large product, the primary key, or the way the customer is identified, is it the name? Is it name plus address? Is it name plus something else? Subscription ID, so on and so forth. It becomes highly non-trivial. So to coordinate and actually enforce things like GDPR and CCPA, huge battle scar, right? And again, there is no, if this is not automated in the form of making it self-serve for the data users that are working within the company, this is not scalable, right? Because the number of customers can be in millions depending upon what you're doing. What I'll do, folks, is I'll just quickly talk to the headline of the battle scar, not go into details of the slide, and then wrap up the top 10. The next battle scar here is, hey, job pipeline ran for 15 hours, right? And typically when these job pipelines complete, then you figure out, oh, there was a data quality problem. There was a null all along. So the result that I'm going to see, it's useless, right? The marketing numbers are wrong, or the model training exercise was potentially useless because these data quality issues existed in the data, right? And typically you discover them once you try to see you're not getting the right results. If it's a dashboard, you see a random spike which you can't explain. You go back and say, oops, this had a data quality issue. So this is one of those where long-running jobs, if it takes 15 hours, there is no way you can rerun that, like, and get your data point for the day, right? So getting proactive, and again, how to make sure the observability is self-service so that everybody can actually leverage it and handle these kinds of scars. And again, bunch of tools out there that do AI-driven automated tuning for these jobs, such that you can truly optimize and meet the SLAs that are in play. Wrapping up a few more, polyglot data stores. Every company has very interesting combinations of key value stores, graph databases, document stores, how to effectively write queries. I have basically seen some interesting exercises where when you go to write a query that joins data across data in a bunch of different data stores, not easy to manage and maintain. Second last here, A/B experimentation, ABN experimentation, having a way to analyze the data. And this again goes into this thing of what slows us down. Like, I've been doing a lot of A/B experimentation, but guess what? How do I look at the results? And in my experience, we tend to reinvent the wheel. So the experimentation matrix for increase in gross sales or the lift, guess what? The definition is different from the metric for gross sales that is used by the business team. And a lot of effort in experimentation actually goes in analyzing the results and building all the data pipelines that are required for that. So clearly an area, self-service, not really from the running the experiment standpoint, but actually running the analysis on the data, sort of building that out. And the last one here is cost. This is, again, doesn't directly hit the data users directly, but the key point here is, especially if you're in the cloud, there's a linear usage model, and keeping ahead of it, what we refer to as cost governance. And there was a week when we were sort of experimenting with some models and trying to get some data, run some pipelines. Long story short, it was much bigger than what we thought. Just in a week, we blew up $80,000 on the, and it was just an experiment. It's like, wasn't even a serious thing that we wanted to do. So folks, hopefully you get a sense of some of these hurdles and have a better appreciation of some real world scenarios that that exist. And again, I had to rush through it, but again, there's a good story behind each one of it. And I also try to give you a flavor of how to manage the hurdle. Like, there's no hurdle that cannot be done. The general mantra that I have applied is making it self-service, because that, in my mind, is the best way when you think about really democratizing. When we talk about democratizing the data platform, it's really these hurdles that you want to democratize, is that anyone can be solving these. So the second part of my talk, and this is really going to be about 5 to 7 minutes, that's the time I have, is how do you map it in your world, managing your data ops, right? And the way I prefix this is that the hurdles I talked about, there's no universal list here. In fact, I think of these hurdles as a people, process, technology problem. And what I mean by that is, if you're a startup, right, with 10 data sets, right, or in my analogy I also have is, you may have a small number of large tables or a large number of small tables, right? So companies like Netflix, they have a small number of very large tables, right? There, when you think about data, discovering data, some of those issues are less critical, right? Versus on the other extreme, if you have a large number of small tables. One of my previous roles, we used to ingest data coming in from the transactional data stores, and there's 20,000 plus tables ingested every day, right? So that's an example of the other extreme. A lot of things can go wrong at that point. So nevertheless, these hurdles tend to be a combination of data, process, and technology. Maturity curves are different. Brownfield versus greenfield deployments, they all vary. And when you think about your data ops, right, especially also when we think about self-service, I also like to clarify that when you think of self-service, don't think of self-service as a binary. In fact, an analogy here is a self-driving car, right? And it's referred to as levels of automation. So 0 is no automation. And we're still not on level 5. There's no self-driving car with level 5. It's an experimentation. But level 4 we have got there. Level 3, pretty much a lot of cars today have it. And that's the same approach we need to be thinking about, especially when you think about automation. Don't think of it as either it's self-serve or not. It's the level of self-service. So my concrete thing here essentially would be the very first step with your DataOps is to measure it. If you cannot measure it, there's no way you can improve it. And I have struggled in my experience quite a bit in not, there'll always be burning fires, and we tend to get reactive. In fact, a lot of what I've seen happen, even working with peers, is you sort of chase the next shiny technology, right? And when you go look back, it's like, why did I buy this? Like, how is this helping me with any of my problems? Really not. So what I'm going to share in the next 3 to 5 minutes is really an approach that I have followed. And this is something that you can be applying in your space as well. So the very first thing in terms of thinking about data ops is, what is the overall metric? And the metric, I refer to this metric as time to insight. So time to insight is all the steps that are involved to go from discover, prep, build, and operationalize. So time to insight is the overall, I would say, metric to look for. Now, time to insight, as we were going through the hurdles, right, and talking about the different building blocks, is actually a summation. So the overall time to insight is basically all the key milestones you need to achieve in each of the buckets, right? So in the discover bucket, it's the time it took me to search the data, right? If I cannot search it, there's nothing I can do about it. Followed by time to interpret. Where is the data coming from? What's the lineage? So on and so forth, right? Time to featureize. Obviously, a lot is then, there are some aspects we didn't talk about, the need for feature stores, right? Which is becoming more and more popular, because that's how you can amortize the cost of building models. If you don't really have features, then you're actually trying to move data yourself. So how much time it took to move that attributes into the lake so I can start building my model, so on and so forth. So in the interest of time, I'll just leave you at this point in terms of, think of this as a scorecard. And the key point here is, if you break this problem down, there are basically 18 metrics, and there can be more, there can be less. This is the 18 which are most critical based on my experience. And there are several sub pieces within them that exist as well. There's an exercise that, in terms of making things actionable, is to actually follow and say, okay, in my situation, my process technology, people combination based on my needs, what is slowing me down, right? I've done this exercise with a few different peers, and the colors are always different for these boxes, right? And it's very interesting. Like, smaller companies, the prep becomes more critical. Larger companies, operationalize becomes more critical. Well-structured, like if you're a mature large company, it's operationalized. If the maturity curve is low, the discover side tends to be all in the red, things like that. But nevertheless, this is the very first step, where the idea here is to take a good hard look at what is slowing you down in the data ops journey, right? And then really sort of, I would say, the call to action here is, think of data ops in a lean fashion, right? But you cannot change it overnight. In fact, that's the mistake I've tried to do, right? If you put emphasis on everything at the same time, guess what? Nothing gets done, right? So really starting by step one, measuring what your scorecard looks like, which is different for everyone. Second, within that, shortlisting 1 or 2 metrics. In fact, we used to do this on an every quarter basis, like look at it every quarter and say, okay, this is the 1 or 2 metrics I'm going to work on, and change the level of automation. So self-serve, again, it's not a 0 or 1. Basically, how do I get to the next level? How do I, if I'm indexing the data, how do I now sort of think about search? If I'm searching the data, how do I make it more robust and make it available for everyone through access control? So that's how you would sort of approach this. And the third piece is build it out. And as you think of building, clearly no need to reinvent the wheel. There are design patterns out there which really exist in these buckets. And these design patterns, I'm emphasizing patterns, not technologies, because the patterns are what you need to apply. If you're moving data, there's a pattern of batch, pattern of real time, pattern of streaming. Now, that pattern will have a technology which will be different in Google versus AWS versus on-prem, so on and so forth. So understanding that and then saying, okay, this is the pattern we need. Now let's go and get the right technology is going to be the approach. So that's pretty much it, folks, in terms of summarizing the point I want to leave you at. Now, this is something that I've been passionate about. In fact, for those of you who want more details on these buckets and what the patterns are, I'm fortunate to just have summarized it in a book. So there's a book coming out in actually next month, and there's an early release version on O'Reilly that you can go and check out. But that's really where that's all I want to cover, and looks like I'm a minute over. Thank you, everyone. I'm open for questions now.
Thank you very much, Sandeep. Let's see. I have a few questions, everyone. Oh, actually, good. So there are questions. So there's a first question on the Q&A, Sandeep. I think we can answer them live now because we're in the Q&A.
Sure.
Everyone else, add your questions.
So Nisha, I'm trying to get to the Q&A.
You can stop sharing, by the way, if you'd like. That would probably be the easiest way for you to find your Q&A.
Now I get it. Okay, thank you. So the first question I see here is from Umesh. Self-service is a great approach. Do you see any downsides in this approach? So the way I would basically put this is, when you think of self-service, think of the democratization, right? And like anything else, it has to be a balancing act with respect to governance and access control, right? So for instance, I will give an example. I was talking about the battle scar of search, right? Of trying to search a data set. Now, if you build out that service, end of the day, there will be some data sets which are access controlled, right? There will be some data sets from finance which should not actually show up. So I would basically put it as the downside here essentially is really making sure that in the process of making it self-service, we have the right guardrails in terms of, like, if folks are spinning up their jobs, are able to schedule, so on and so forth. There's an extreme here of, speeding up, but at the same time being misused, as well as the other dimension of guardrails are governance and access control. So those are the things I would really say. I wouldn't call them downsides, but something you have to be very, very cognizant about as you build these things up. Okay, moving to the next question here. Are there any ML approaches to solve the DataOps challenges, especially when handling bigger data sets and massive pipelines? That's a great question, Venkata. In fact, the way I would basically think about how machine learning helps solve, right? Again, just taking an example very close to home with Unravel Data, which is the company, which is a product I lead, where the whole intent is how do you really transform by analyzing the current runtime, right? So when you're running these large data pipelines, when there's a SLA mess, or you need to figure out what is the best way to run this Spark app, right? Oftentimes humans have limited, I would say, abilities, right? In terms of, how well we can actually debug, we can actually figure things out. And this is exactly where, a great example of how MLOps truly excels. In fact, if I can just quickly share just one thing here from the deck to drive this point home. Just to give you a real example here to MLOps in progress, right? This is basically a Spark app, right? And this app, essentially, when it first ran, it failed, right? So it ran for 15 plus minutes and it failed due to out of memory, right? Now for this one, in the Unravel product that I'm leading, we have this aspect of ML applying machine learning, where if you put it in auto tuning mode, there's a reinforcement learning that is happening under the covers, where Unravel then tunes the parameters. So what you're seeing here is in the second run, the run actually completed because, and again, I'm happy to talk more about the AI-driven algorithm we use internally. Second run took 4 minutes, right? third run 1 minute, so on and so forth. Eventually, there's only so much optimization you can do. But this is an example to Venkata, your question of leveraging this in this context. Okay, continuing here.
Yeah, so others folks, if you have questions, please add them. So I think I had a question, Sandeep, which I think we partly answered in the context of Ramesh's question, which is sort of this balance between self-service and guardrails, right? And I'm kind of curious as to which comes first, or do they all come together? Right? Do you put the self-service out there first, wait for something to explode, and then put the guardrails, or do you put them together, or
That's
you know what I mean?
It's a chicken and egg, right?
Yeah.
Basically, how do you apply this? I think in my experience, we have typically sort of applied it in the sense that the first iteration tends to be without guardrails, right? But then you limit it to the benign data sets. You limit it to a subset of clusters that are free all. And what you're really learning during that phase is how are users sort of using that, right? What pattern, what are they searching for, and this is where it's more of that learning, because with a broader set that is free for all, the learning increases in terms of how do you make sure that we have the right tool in place. Once that is struck, once there's no new learning, then you start going up the pyramid and say, okay, now how do I put more guardrails around this, including access control, integrate with your tables, so on and so forth. So that has been a typical approach.
No, makes a lot of sense. I think the direction towards self-service, you kind of see it in many organizations, right? It just makes so much. It also integrates so well with automation, and it just
absolutely
complementary concepts. Yeah.
Yeah, and I think it would be amiss to say that it's flawless. I think in the journey, definitely I've made a lot of mistakes. There have been interesting things. Governance, for instance, is an interesting example as well, as a battle scar. Just getting it right? How do you really sort of catalog the data sets, catalog all the data that belongs to a customer, right? There's this classic example where, as a customer, I said, I don't want email. I had no preference, remove that, but you still get an email, right?
Yeah, there are a few things that would annoy a customer more than that. Yes.
Absolutely.
It's a very personal thing. So absolutely.
Totally.
No, makes sense. Thank you so much, Sandeep. This was a really great talk. I appreciate it. So I think we have 1 more minute if anybody wants to ask any questions. If you have any other questions, please do put them into the Q&A. I think, yes, somebody put a thank you as well into